Hello, thank you for having me here today, inviting me to the esteemed Ashoka Institute of Technology and Management. It's my honor to be here today and speak with all of you. My name is Grace Eden, and I conduct teaching and research in something called human-computer interaction, which I'll talk about, and interface design. So today I will be talking about how to integrate ethics into technology development. And what do we mean by ethics? So my discipline, I was trained in a computer science department, but my discipline is in the social sciences. And my interest is how people and technology interact together. And this field of study is called human-computer interaction. And it's also called, one of the processes we follow is something called user-centered design. Has anybody in here heard of user-centered design? Raise your hand. Anyone? Okay, so you'll learn something today, at least from this slide, right? So user-centered design is focused on how we can understand user needs. Is there a laser? So what we do when we're in a project, we need to understand what the needs are of the user. So how do we do this? We don't just build, in corporate environments, Facebook, Google, OpenAI, they don't just build the technology without consulting, without doing a little research about what the user needs. So there's a whole process for trying to understand what users need. And you might hear this term called requirements engineering. So the idea is to gather the requirements of the user. How do you do that? You need to go out and talk to your users. You need to go out and interview your users, right? So in the user-centered design process, we start with defining user requirements by interviewing users, visiting them in the workplace. So if we're building a technology for a hospital, let's say we're building a technology for an operating room, we need to talk to doctors to find out how they do things in the operating room and how the technology will complement what they do rather than create an obstacle. So when we're integrating a new tool into an environment, we need to understand how tools are currently being used in that environment. That's very important because we don't want to disrupt what's going on. So we interview users by defining requirements, we observe them doing their work. Then from that, we distill some basic requirements and come up with concept designs. So this is all front-end stuff, right? User-centered design is the interface part. It's not the coding part. It's not the technical architecture part. It's the part that the user interacts with. So the screens, right? Human-computer interaction is about how do people interact with the screens. So then we come up with some general layouts for screens, and then how people will walk through the different screens, right? So we'll come up with a general sequence of how a task will be completed, and then we'll check with users to see if they can understand what's on the screen, the layout of things on the screen, if the words on the screen make sense, if the steps make sense to them. So this is an iterative process, which is why you see these arrows. So we're always going back to the user in a user-centered design process. It's not just about making software and then you'll hear this term, throwing it over the wall and hoping people will use it. We can't hope people will use it, especially if we're spending lots of money, right? Let's say we're building a piece of software for a government agency to complete some tasks. We need to know how they do those tasks now to complement that work. If we build a system without knowing these things, it could disrupt the entire process. So we'll come up with some concepts, we'll test those, we'll create prototypes, and we'll test those with users. Now these prototypes are usually just paper-based, so we'll just do some sketching on paper, or we will do some sketching in a piece of software. There's something called balsamic If you haven't heard of Balsamic, you might want to download it and test it out. It's a piece of software used for creating interfaces for websites and apps. So then after that, we will start working with the software engineers. So the back end can be linked to the front end, to the interface. As the prototype becomes more of an actual product, we'll test it in the field. So we'll actually bring it on site, let's say an operating room, and we'll test that system on site to see how easy or difficult it is for people to use and for it to be integrated into that environment. And again, this is iterative. Iterative means going over it again and again until it satisfies your users. After we do a field trial, then finally we will do a product launch. But the product launch, you know, for instance, when you're using Microsoft Office, sometimes you might get a notification, will you answer this survey, or can you give us some feedback about what you like and what you don't like about the system? So we're always getting feedback from the consumer so we can improve this user experience. Have you guys heard this term user experience? Does someone want to? Anyone who's heard user experience? Okay. It's called user experience. And it is a huge part of corporate software development now. Every major corporation will have a user experience department. And they work directly with users. They're like the bridge between the user and the programmers. You'll have the user experience group here to talk to the user group, to talk to the software engineers, right? So that's what HCI is. That's the field that I'm in. And one of the things we're interested in our community of researchers is ethical considerations around technology development. So we want to know, for instance, do people feel safe in a driverless car? If they don't feel safe, why don't they feel safe? How can we make them feel safe? So we're trying to understand people's perceptions. What do they think about ChatGPT? Do they use ChatGPT? How do they use it? But when we're talking about ethics, we want to answer these 7 key questions. So who benefits? Who benefits when we're building this technology? Are we building a surveillance technology that will perhaps impinge on people's privacy? So who benefits from this technology? So that means let's identify the stakeholders. Who's asking for the system to be built? What could the potential implications be for the users of those systems? Another question we want to ask is, what are the risks? So when we're asking this question, we want to try to identify potential negative consequences. It doesn't mean these negative consequences will actually happen, but just to anticipate. Let's anticipate what might go wrong. Then the third one, what if we're wrong? What if we build a system that actually isn't going to work? So in this question, we want to come up with a contingency plan. So one example of this is in London in the 70s. I think they were trying to automate the London ambulance experience, ambulance drivers. So they were using some kind of machine learning software to assign ambulances to different parts of London. But what happened with that is it started doing the work that drivers were used to doing. So for instance, drivers know certain parts of the city really well, right? The small roads, the shortcuts. But when this algorithm took over, it would put drivers into neighborhoods that they didn't know very well. And so they would wind up getting lost, and people who called for an ambulance were waiting longer. Another thing it did was it put ambulances in these weird clusters around the city. So some ambulances were clustered in the north, and if someone called from the south, the ambulance wasn't coming for hours. So they had to stop the program. If you Google it, I think it was in the 80s, 1980s London ambulance software issues. You'll find lots of articles about it. So what if it goes wrong? What's the backup plan? Do we unplug it? How do we unplug it? How do we stop the system? The fourth one is, what are the alternatives? So rather than just thinking up one design idea, let's come up with a few alternatives. So for instance, if we're talking about privacy, how can we create software that's privacy enhancing rather than taking away people's privacy? For instance, can we come up with different types of features and functionality for the same product and have, maybe 4 alternatives to walk through with users and with your other stakeholders? The fifth point is who decides. So when we build software, whether it's for a company or a government agency, we need to identify the individuals or groups who have the authority to make the final decision. I've been in software projects many times where we've interviewed users and they've had a specific request, but it didn't go through because the person in authority, the person who decided, said, it'll cost too much money, or we don't have time for it, right? So when we're planning our software development, we need to think about who decides and how do we engage with that person. So the user experience group will also work with the project managers, right? This is kind of a project manager task as well. How do we anticipate our relationship with our stakeholders? The sixth thing to consider is who's in control. So who has the power to implement the software and to influence the process of the software development? So for instance, who has the power to say, yes, we're going to incorporate users into our software development project? And the final one is who's responsible. So who is accountable if something goes wrong? So we can look at Tesla cars for an example. A few Tesla cars have actually killed people. Who's responsible for that? Is it the software developer? Is it the CEO? So we need to ask these. So asking these questions will help us formulate a path forward. So user experience, human-computer interaction is all about asking questions, planning, and trying to understand the implications of our research. So not just building something for the sake of it. That's fine too, but that's not applied research. That would be fundamental research. Applied research is when you're affecting people. And so when you're affecting people in my community of human-computer interaction, we feel like we have a responsibility to ask these questions before we start developing. So in this diagram, you will see the basic lens that we look at the world through. It's called a socio-technical system. So a socio-technical system is where you see society on the left of the diagram and technology on the right. These two things interact, and you have this thing called a socio-technical system in the middle. So what is the interrelationship between us and technologies? And this could be a traffic light system. A traffic lighting system is a technology. Are the traffic lights paced in such a way that you can go through a main road relatively smoothly? Or are the traffic lights sequenced in such a way that you're always stopping, wasting petrol, and annoying people, right? So that's how we look at the world. What is the interrelationship between any technology, traffic light system, software system, and the people who are using or interacting with that technology? Now, of course we have AI, right? AI has kind of came on the scene in, was it 2022? Maybe 2021? So it's AI, ChatGPT, it's now kind of the main focus of everyone in, most people in computer science, most of their work, and most people who work in technology and ethics. They're concerned with AI specifically. So let's talk about the compatibility between computer science and human-computer interaction. So both disciplines are interested in problem solving. A computer scientist wants to solve a problem from a technical perspective, identify a problem space, and find some solutions. A researcher in HCI wants to identify problems between the interaction. What are the problems between people and technology? What's that problem space, and how can we solve that problem? Another thing that we share is that we're working on innovative products and services and emerging technologies. So anybody who's trained in HCI, human-computer interaction, most likely does this in the computer science department. So when you get your master's degree, when you get your PhD, it will be in the computer science department, although you're not doing any coding. So it concerns computer science, also design in the arts. How do we make a interface look nice, pleasing for people, something that makes sense to them? It also involves psychology. How do people perceive color? Does it affect their motor skills? Let's say an airline pilot. People create those interfaces for cockpits, right? Where do we put all the gauges? Can the pilot reach something quickly if there's an emergency, right? All of that is HCI. All of that is, but you're looking at the psychology aspect. And, of course, social sciences. So how do groups of people interact with the technology, and does it change group behavior, right? So psychology is more about individual behavior, and sociology is more about group behavior. So yeah, I think these are the kind of differences. Computer science is interested in coding, algorithm design, data structures. Human-computer interaction is interested in interaction design, how people communicate with each other through technology, and how behavior might change. So in human-centered AI, how long do I have? Sorry. In human-centered AI, so now we have this thing called artificial intelligence, right? So how do we create human-centered AI? Before AI, it was called human-computer interaction. Computers, right? Or even technology. But now we're talking about AI. How can we create human-centered AI? So this is a very challenging topic because it's new. But we've identified in our community, we've identified some components that we need to look at. So of course, the fundamental one is looking at human requirements. What do humans need from AI? We also need to look at the ethical requirements. And there have been many institutes of AI ethics that have opened across the world to look at these questions. And of course, an HCI researcher will look at how AI will enhance human abilities, so enhance human knowledge. And one of the key interface questions is how can we build systems where the human understands why the AI gave that decision? So, for instance, there was a big problem with LinkedIn using some kind of, they were hiring people, again, Google it, you'll find it. They were hiring people for jobs, and they were using some kind of AI algorithm to sift through the job applications, and it was biased towards who else? White men, right? And why was it biased? Because the system was looking, it was prioritizing resumes through some kind of algorithm that picked up keywords that Western white men use a lot, or something similar. So everybody on the top of the stack were all Western white men. And it was discovered within LinkedIn, so they had to change the algorithm. This has happened, of course, in facial recognition. There was a researcher from MIT who did some research on who was getting selected at airports to have all their bags checked. And again, it was biased towards people with white features, right? Why? Because we have these Western white developers creating these systems. However, the big companies have recognized this. And one of the key things about creating ethical systems is to have diverse workforces. So have people from, Eastern Europe, Western Europe, Africa, Asia, India, and America, North America, South America. You need to have diverse groups of people because then you will have diverse opinions. Somebody from a low income group versus a high income group might see something that others don't, right? So it's important to have diverse workforce to help identify these problems with bias. There's a huge research area on algorithmic bias. If you're interested, look it up. And how these systems could potentially discriminate against certain types of people. And sometimes it's not intentional. It's just that the developers didn't see it. And they didn't see it because they don't have a diverse workforce, or because they don't ask these questions. They don't ask these questions. That's why it's very, very, very important to ask these types of questions when we're building systems that affect people's lives. So let's look at some issues around AI and image classification. You might find this interesting, on image classification. How AI gets it wrong. So this is the famous blueberry muffin in Chihuahua. Okay? So the system, it's probably changed now since AI, I don't know, maybe it's gotten better. But here, machine learning systems cannot recognize the difference between a Chihuahua dog and a blueberry muffin. Okay? The next one is ice cream and Dalmatians. Which one is the ice cream and which one is the dog? We can see it, but for some machine learning systems, it's very, very difficult. And this is the dog versus bagel experiment. Again, machine learning systems might have a very difficult time identifying dogs or bagels. So these are fun, but in a more serious environment, it might have more serious consequences for people, right? Like, for instance, I think train stations in Europe and America are putting in surveillance cameras that will try to analyze people's behavior. So if you're walking a certain way, or holding your head a certain way, or have a certain facial expression, it'll try to guess or assume, try to recognize a pattern on if you are carrying drugs or if you are a potential criminal. Well, that could infringe on our rights, right? Because if you can't get this right, and why is it interpreting behavior in a way that may be incorrect? Maybe somebody just walks with a slouch. Maybe that's just the way it is. So we have to be careful about how we're using these systems to make assumptions about people, right? So this case happened in 2022, and this was a chess tournament in, I believe it was in Russia. In the summer of 2022, this boy was playing chess with an AI robot arm. And the robotic arm broke the boy's finger. It got stuck, they couldn't get it out. And this happened because, according to an article about this event, the child violated safety rules by taking a turn too quickly. So when he was moving his chess piece, somehow the child violated safety rules by doing it too quickly, and then the arm grabbed his finger. Now, if you look at this video, I do not see the child's hand moving quickly at all. Rather, I see this arm moving really erratically. The child seems to be doing it at a normal speed. But even if the child violated some safety rule, was he told about it? How fast is too fast? So these can cause actual physical harm, these systems, to people, when ordinary people start interacting with AI robots or even AI software systems. The consequences are more substantial. For instance, if you're in a factory, right? Let's say robotic arms are building cars all the time, but people in those environments are trained to work side by side with those systems. But when we have the general public coming and interacting with these systems, for instance, this arm, but we can also think about autonomous vehicles. We can think of a spectrum of activities that humans may not know what the limits of the system are and how it will behave. So for instance, I was on a project on autonomous vehicles, and we ran an autonomous vehicle in a small town in Europe. And we had a video camera on the inside and on the outside to see how people were interacting with it. And many people would try to block the vehicle. So they would just stand in front of it, or they would stick their leg out because they knew it was going to stop, right? So, sometimes people will try to game, you've heard of like gaming the system, or trick the AI system to do something it's not supposed to do. So in this case, we need to think about explainability. How can we explain to ordinary people how a system works and how it makes decisions, and how we, humans, can interact with these systems in a safe way. So this comes to values again and responsibility. So when we're talking about values, we want to have a certain level of values can be thought of as principles or standards that we think are good, right? And we need to create those principles and standards. So for instance, in robotics, I think there are these principles. There's a principle called Asimov's laws about robotics, and I think Asimov was a science fiction writer, but actually many computer scientists took his principles called Asimov's laws and are trying to implement those values into the design of system. What are those laws? Those laws are robots or AI should not harm people. They should not harm themselves unless it harms people. Do you remember the third one? There's three. I can Google them, but Google them. Asimov, A-S-I-M-O-V, Asimov's robotic laws. Those are values that we try to kind of build into AI or robotic systems. And computer scientists are using these principles to try to instill some sense of ethics into these systems. So for the research, in Europe and America, and even here, there is have you heard, Niti Ayogi? They have an AI white paper, AI and ethics white paper. So many countries around the world are talking about how can we innovate responsibly. And again, that focuses on reflection. So the researcher needs to reflect and ask questions about what they're doing. And inclusion. What's inclusion? Talking to stakeholders. So this is the social science side, right? We want computer scientists and researchers to be a little more, soft science. Think about soft science issues. Reflect upon what they're doing and include the general public in a dialogue about the research that they're doing. So this idea of responsible research and innovation came about, its origins were in the physical and life sciences, because these new technologies were being developed, and governments and universities wanted to know what we should do about them. For instance, nanotechnology. Scientists are creating these molecular scale materials that we can't even see. We can't see ourselves, ordinary people. But what if it's put into cloth? What will happen? What if we breathe these things in, right? So this is an area for concern. Another is synthetic biology. Many researchers are constructing biological devices through this scientific field called synthetic biology, where they're actually creating biological machines. So what are the implications for us as humans if these...
3D bioprinter?
Yeah, 3D bioprinter, but they're also creating like pumps and valves you can put into your heart, things like that. Then there's another area called geoengineering. And because of climate change, scientists are starting to work on how we can make the Earth cooler. So many scientists are working on developing aerosols to spray into the atmosphere. Some scientists are talking about putting up these reflectors into space, high Earth orbit to reflect the sun. So this will affect global climate. So it'll affect everybody. And what if it goes wrong, right? That's when we ask those questions from the first slide. Do we have alternatives? What if it goes wrong? How can we stop it, right? So as technology gets more and more sophisticated, it's going to have a greater and greater impact on us. So in traditional research, we were always just really interested in our own academic work, publishing papers, getting funding, maybe doing some outreach at a school or at a community center. But because these technologies are becoming more sophisticated, meaning research funders, are asking scientists to do more and to think about the ethics. So I think I only have 5 more slides, and it's about ICT in general, or computers in general. So when we're talking about ethics in ICT, information computer technology, there are 5 characteristics that make it a challenge. So think about airlines. Airlines are regulated, right? Pilots can only work, 8 hours a day or something. They can't do like 2 overnight, they can't do a Delhi to New York flight back to back. They have to rest for maybe a day, and then they can. Plus, there's regulation on the equipment. All the equipment has to be inspected. Maybe some has to be inspected every flight. Some needs to be inspected every 2 weeks, right? There's a whole regulation framework around every industry, most industries. But in ICT, it's a little different. So let's talk about these 5 reasons why it's different, which are discovering risks and uncertainty are a little more difficult. The process or rhythm of ICT outputs, something called logical malleability, which I'll explain, the problem of many hands, again I'll explain, and the notion of convergence. So the first one, discovering risk and uncertainty. So in the life sciences, we have actual material that we can work with, biological or synthetic. Whereas in software engineering and hardware, sometimes people just release a software program on the internet, like in GitHub, right? You can just release something. There's no process of health and safety or risk assessment. Anyone can release anything. That's why we have viruses and phishing, and, right? Anyone can release anything at any time. There's no kind of gateway, whereas there's no gatekeeper. So this is the only industry really that doesn't have a gatekeeper. Aviation has a gatekeeper, nuclear power plants have gatekeepers, train technology has gatekeepers. There's no gatekeeper because we have the internet. We can just put everything online. So that's very difficult, right? That's a big challenge right there. The second is that software development happens at a much quicker pace than traditional sciences. Something could be developed in a week and then go viral in 24 hours. So again, having some kind of gateway or gatekeeper between the technology and the general public becomes more difficult. Now, what I'm telling you now is what funders and governments are concerned about, right? They're concerned about controlling potential problems. And then there's something called logical malleability. That means that if I create a piece of software and it's open source, someone could tweak that software and make it do something not completely different, but slightly different, where it becomes a menace. So you can have a piece of software that is originally intended to do something positive, let's say it's in a cybersecurity realm, and someone could take that open source software and fork it or make it different, slightly change it, and create a malevolent piece of software built on the back of something that other people have been working on. Easy to do, and lots of people do it. Then the other issue is the problem of many hands. So this is when a piece of software, if you have a company developing software, many people are working on the code, right? And you kind of maybe might lose track, although there are versioning systems and you can have people comment in their name. But because the software goes through many people and it's available to everybody in the organization, somebody could slip some code in there that could, again, make the system do something. There is an example, and it could be, I don't want to say, it might have been the LinkedIn example. The code wasn't checked thoroughly. So, and in large systems, it becomes more and more difficult to check code for malicious entries into it. And then finally, the notion of convergence, which is the boundaries between different types of systems is converging. So it's not just software and laptops anymore, it's software, it's ubiquitous computing, it's sensors in the environment, it's robotics and AI, right? All of that is kind of potentially immersing whole environments. So we're not just dealing with just one piece of software, we're dealing with an ecosystem of technologies. So let me just show you one last thing, which is a tool online that you can use if you're interested. But when we're talking about integrating ethical considerations into technology development, it's looking at how we do research that takes a long-term perspective and thinks about the type of world we want to live in. What world are we creating for our children? What world do we want in 50 years? So we're really asking that question. So there's a website that takes you through a series of questions that you can use to anticipate potential problems, reflect, engage with stakeholders, and act. So maybe change your course of research if you would like. And this framework is free for anyone to use, and this is the web address here. I can show it to you. So basically it just takes you through steps for reflecting. So if you want to reflect, there's a process, perhaps have an advisory board, right? That's a nice thing to have. Some people from outside your project to give you advice or perspective that you might not have. think about the potential uses, what are the purposes. So these are just a series of questions to ask yourself and your group to ask for thinking about how to create an environment, a setting, where everybody in your team is thinking about the long-term view and thinking about inclusion and reflecting upon the consequences. So if you're interested in this website, I could email it and it could be distributed. And it will give you a framework for starting to think about these kinds of topics in your own research. Okay, I think that's it. So thank you. I hope this was useful.